Hey everybody, in this video we will be talking about the science of psychology. So every psychology class ever starts out with a definition of psychology. In this class we will refer to the study of psychology as the study of human behaviors and mental processes. Specifically, we are interested in describing, explaining, and predicting. We want to describe behaviors and we want to explain how mental processes work. For instance, what is the mechanism that underlies our ability to selectively attend to one thing while tuning out irrelevant stimuli? Finally, we want our knowledge to have some kind of functional importance. That is, we want to be able to make useful predictions about those processes. What will things look like in the future? For example, if a researcher notices that scores on a particular achievement test can be used to predict college dropout rates, then we can use that information to estimate how many students in a particular cohort or group might drop out of college each year. When we talk about describing, explaining, and predicting behavior and mental processes, we're talking about the utilization of knowledge. And all knowledge comes from somewhere. But what's really relevant to our discussions is that knowing the source of the knowledge is just as important as knowing the knowledge itself. Is this knowledge coming from your gut feelings about the world or from the scientific literature? There are a ton of areas in psychology. The American Psychological Association actually identifies 54 different divisions of psychology. For instance, there's clinical psych, social, cognitive, neuroscience, developmental psych, and many more. But what's great about all of these fields is that they are united by the same core set of research methods. So we're able to trust the source of that knowledge. So what are the different sources of knowledge? Well, one source of knowledge comes from tradition. People believe things because that's the way they've always believed, and that's what they've always believed. However, just because something was a tradition doesn't make it true. Traditionally, teachers were allowed to hit students, and today that's not allowed because we know that alternative rewards work better than physical punishment, among other reasons. Also, just because something is a tradition doesn't make it automatically false either. Traditionally, teachers make students write papers and take exams. Well, we still do this today because there's evidence to show that writing papers and taking exams helps to promote student learning. Related to this, we can think of some common sayings like opposites attract or birds of a feather flock together. These are pretty catchy sayings. I hear them all the time, but just because something is catchy or memorable doesn't mean that it's true. Another source of knowledge comes from our intuition. We carry beliefs about the world based on gut feelings, our emotions, and instincts. You can have moral intuitions, feelings about something that might be right or wrong, such as animal rights. There can be political intuitions or feelings about society. There can be interpersonal intuitions related to good or bad interpersonal skills. It's important to distinguish these from observations, however. An intuition is something you feel, whereas an observation is something that you see in the real world. While it's true that technically an intuition can be considered a type of observation, it's not really an observation about the world around you. Intuitions can be pretty helpful in our daily lives and can sometimes be useful for science, but they aren't always empirical or reliable. A big way people acquire knowledge is through authority. This is when people believe something someone says because they're smart or powerful. You listen to your parents growing up, you listen to what your doctor tells you to do, you believe your local politicians on various types of policies. Again, this can be pretty useful, especially when you trust that individual, but sometimes this can lead us astray as well. Sigmund Freud said that most people don't really want freedom because freedom involves responsibility, and most people are frightened of responsibility. It can be pretty economically efficient to gain knowledge from authority. It saves us a lot of time and resources instead of having to figure out every single thing about the world ourselves. While this can help inform the scientific process, we should also be careful of blind acceptance of all knowledge from authority. Another source of knowledge comes from rationalism. This is where we use logic and reason to acquire knowledge. An example of using this to come to valid conclusions is that all dogs have a good sense of smell. Tucker is a dog, and therefore Tucker has a good sense of smell. A lot of people take these types of logical statements as truths. A lot of times they are, but they're also susceptible to a lot of other sources of knowledge. Entire premises can be wrong, or there can be errors in logic that we aren't aware of that can lead to invalid conclusions. The last source of knowledge that we'll talk about is the scientific method, and let's unpack that a little bit. First of all, everything we interact with every single day can be thought of scientifically. When it comes to understanding human behaviors and mental processes, psychology is a science. And science deals with three main things. The first is systematic empiricism. Empiricism is acquiring knowledge through observation and experience. Observations are really insightful, but sometimes not. For a long time, people observed their flat environments and therefore thought that Earth was flat. But empiricism is at the heart of the scientific method. Science relies on observations, but observations that are systematic. They are structured and observed under controlled conditions. The second main area science is concerned with are empirical questions. These are questions about the way the world works. And importantly, these are questions that can be tested and answered by systematic observations. Examples of empirical questions include what causes the seasons to change, or why can we only keep a few items in mind at any one given moment? There are other types of questions that aren't empirical, things that concern values, what's good or bad, or what makes something subjectively beautiful or ugly, and so forth. The third main branch of science is public knowledge. After running experiments, scientists disseminate their findings. They write up their research results and they publish their findings in peer-reviewed academic journals. A lot of research especially depends on public funding, for instance, research grants from the National Science Foundation or the National Institutes of Health. The public therefore has a right to read research that they helped fund. Public knowledge is also important because science is inherently a social process. Researchers collaborate with other researchers to run projects together. Scientists go to academic conferences and share their research with each other. They get feedback on this. Science is therefore a self-correcting field. Some experimental findings can be pretty seriously flawed. They can be flat out wrong sometimes. But if they're shared publicly, newspapers, media, journals, critiques will come out, rebuttals will come out, and eventually the topic will be corrected. Science generates new knowledge, and this is the main source of knowledge that we use in science and in psychology. We use the scientific method, and this is the process by which we conduct research and learn things. The scientific method generally follows a series of steps, but we'll go over that in more detail in another video. To understand science and to be a critical consumer of evidence and information, it's important to distinguish between science and pseudoscience. We can define pseudoscience as a claim or belief that doesn't include at least one of the three main branches of science: systematic empiricism, empirical questioning, or public knowledge or dissemination. A big aspect with true science is that it has to be falsifiable. Falsifiability is the ability for a theory or a hypothesis to be proven wrong. And there's nothing wrong with your hypothesis being wrong. In fact, it happens more often than not. Whether your hypothesis is correct or not, you learn from observations and you use that to inform future predictions. A lot of pseudoscience is not falsifiable. A good example of this is extrasensory perception, or ESP for short. Think of psychics when you think of this. Psychics sometimes claim that their powers disappear when you observe them too closely. This way, there is no possible observation that could ever count against ESP. For instance, if someone with ESP is able to predict someone's future with better than chance accuracy, that's taken as evidence in favor of ESP. However, if a person predicts the future outcomes with below chance accuracy, They would say that this isn't evidence against ESP because their powers disappear when they're watched too closely. That theory is not falsifiable and it's not scientific. This kind of thinking is important to consider for us, as some of these beliefs are widely held and promoted on TV, in the news, on social media, and so forth. Some people claim to explain some aspect of human behavior and mental processes. Some other examples include biorhythms, astrology, graphology, and even magnetic therapy for pain. As critical consumers of evidence and information, it's important for us to be able to distinguish pseudopsychology from scientific psychology. Okay, so there are three main goals of science. The first is to describe. We want to learn from observations. We want to test new ideas. We want to gather information from, for instance, literature reviews to help gain insight. The second is to predict. When we find a relation between two things, we want to be able to predict new occurrences. I'll go back to my example using achievement test scores to predict college dropout rates. If our knowledge of this relationship is sound, then we should be able to accurately predict or estimate how many students in a particular group will drop out of college. The third is to explain. We want to demonstrate or determine the cause of behavior or the mechanism of something. For example, researchers in my area of study want to explain the mechanism of human memory, where and how our memory is stored in the brain. You'll notice that the goals of science nicely align with our definition of psychology, that is to describe, predict, and explain human behaviors and mental processes. Okay, a quick note on the two main types of research. The first is basic research. This is research simply for the sake of knowing something or to gain a clearer understanding of a branch of science. Examples of questions that are addressed with basic research are how did the universe begin, or what is the genetic code of an animal, or how do memories work? The second main type of research is applied research. This is research conducted to address a practical problem, and it's an immediate problem. A good example of this is the research on cell phone usage and driving. Cell phones distract from good driving, which leads to safety concerns. And this has eventually led to the enactment of laws that limit the use of cell phones while you're driving. Other examples of applied research include studying the treatment of diseases or how to mitigate memory deficits in healthy cognitive aging or someone with a neurological disease such as Alzheimer's. So why would we even need to use the scientific method for psychology anyway? We can reason about a lot of things using our intuition or common sense. This is referred to as folk psychology. And a lot of times our intuitions are correct, but not always. A commonly held belief is that anger can be relieved by so-called letting it out, say by punching something or screaming out loud. However, research actually indicates that this tends to leave people feeling more angry, not less angry. There are a lot of popularized myths about psychology too, and common sense just doesn't quite get us there. For instance, people don't use only 10% of their brains. That would be pretty metabolically inefficient, especially because the brain is such a costly organ to maintain. The brain accounts for about 2% of our body's mass, but takes up a whopping 20% of our body's energy. So we don't only use 10% of our brains, we use all of our brains. Another example, people can experience a crisis, but it's not constrained to their 40s and 50s. It happens pretty equally across all decades of our lives. The majority of people also believe that psychiatric admissions and crimes increase when there's a full moon, which just turns out not to be true. There's no relationship between cycles of the moon and crime. So it's definitely important to use the scientific method to help us with a lot of these misconceptions. So how can we get these beliefs so wrong? Well, we often count on mental shortcuts or heuristics when forming our beliefs. Heuristics are a great mental trick. They're an adaptation that humans have evolved to help save time and resources in making decisions. More often than not, these heuristics are great and they're spot on. They help us in our everyday lives, but not always. Sometimes they can lead to illogical conclusions. An example you might have heard of before is confirmation bias. This is where we tend to seek out information that's consistent with our beliefs, and we disregard information that would refute our beliefs. The problem is that we're all susceptible to these heuristics, even scientists. So, scientists have to remain a healthy level of skepticism, and we have to take notice when phenomena aren't understood yet in the community, or some things that we just simply cannot know. We also critically use evidence as a safeguard against these biases. Here I have a link to a YouTube video that pretty nicely goes over this topic. It's about 6 minutes or so, and I have it on the next slide here.
Hi, I'm Scott Lilienfeld of Emory's Department of Psychology. And in our brief time together today, I'm going to try to persuade you of two important things. First, that none of us, myself included, interprets, evaluates reality in a completely objective, unbiased manner. And number two, that evidence is ultimately our best safeguard against our biases. In essence, it helps to keep us honest. To make these points, I want you to first look at this slide, and I want you to very quickly read the words on that slide. Okay, now I want you to call out what you see on this slide. Most of you are probably seeing a young woman right now. In fact, I can see it too. What you may not have realized is that the words you read right before seeing that slide may have subtly biased you, what psychologists actually call priming, to see the young lady. In fact, had I instead begun the talk with words like aging, old, wrinkles, and so on, many of you probably would have seen an old woman instead. If you can't see her, by the way, here's her nose, here's her mouth. This demonstration, adapted by British artist W.E. Hill, makes a simple but powerful point, namely that our initial beliefs, our initial expectations, can bias our perceptions of reality, leading us to see some things but not others. This demonstration also illustrates what psychologists like to term confirmation bias, which is a deeply ingrained tendency that we're all prone to seek out and interpret evidence consistent with what we believe, and to deny, dismiss, and often distort evidence that is not. And it can so often lead us to think that we are perceiving reality, perceiving truth in an entirely objective fashion, when in fact we're perceiving it in a way that's filtered by our own expectations, our own biases, our own preconceptions. It can also lead us to experience tunnel vision, in which we selectively seek out and look for and experience evidence that is consistent with our beliefs and screen out evidence that is not. Even eminent scientists can fall prey to confirmation bias in a big way. Here's a photograph of the famous astronomer Percival Lowell right around the turn of the 20th century peering into his telescope. According to science historians, Lowell fell prey to what may have been the most prolonged visual illusion in history. Here's what happened. About 30 years earlier, an Italian astronomer, Schiaparelli, had been looking at Mars and had observed what he termed canali on the surface of Mars. Well, canali got translated into canals in English, and some people thought that perhaps what Schiaparelli was observing were the products of some kind of intelligent civilization. It's interesting because right around the same time, a number of canals, including the Suez Canal, had been built on Earth. So the idea of canals was very much in the air in popular culture at the time. Perhaps as a result, Lowell fell prey to confirmation bias. He looked at Mars and saw what he was sure were canals. The more he looked, the more canals he was sure he saw. He ended up seeing over 100 canals on the surface of Mars, canals that we now know to be non-existent. In fact, it wasn't until the mid-1960s when a NASA mission to Mars looked closely at the surface of the red planet that the idea of canals on Mars became firmly refuted. All along, Lowell had been falling prey to a mirage. There's an interesting historical footnote to this story. Lowell reported seeing not only canals on the surface of Mars, but also what he termed numerous spokes on the surface of Venus, spokes that we now know to be non-existent. What was going on there? Well, about a decade ago, group of scientists noticed an uncanny similarity between the spokes that Lowell seemed to have observed and the blood vessels at the back of the human eye. It turns out that due to the unusual construction of his telescope, Lowell almost certainly had actually been observing the blood vessels at the back of his own eye and, consistent with his confirmation bias, interpreting them in line with his expectations. Confirmation bias may also help to explain another puzzling phenomenon, and an important one from a societal perspective. Data that's been collected by a number of people, including some Emory faculty members, suggests that political polarization is at an all-time high. Liberals and conservatives seem to disagree more strongly with each other than at any time in recent history, and often seem to dislike each other more than at any time in recent history. Part of the problem may be that liberals tend to read liberal news sources. They tend to read liberal blogs. They tend to watch liberal TV shows. They tend to have liberal Facebook friends. Conservatives, exactly the opposite. They tend to watch conservative TV shows, have conservative Facebook friends, and the like. So, as a result of social media, the internet, cable, TV, and the like, we can now create pretty much our own private realities. We can create our own echo chambers that continually reinforce our own points of view and that screen out other points of view. Moreover, because of a phenomenon that psychologists term bias blind spot, we tend to perceive confirmation bias in other people, but not in ourselves. In essence, we're blind to our own biases. So as a result, we see ourselves as often perfectly objective, whereas we see others, especially those who do not share our views, as hopelessly biased, hopelessly subjective. The key bottom line message here is that we're all biased and that none of us is perfect. We all have our fallibilities, we all have our imperfections, we all have our biases. And the hallmark of an educated person is the awareness of those biases. The good news is that by becoming better critical thinkers, we can learn to overcome these biases and take that critical thinking with us outside of the classroom and into everyday life.
Sorry the quality wasn't that great on the video on the previous slide, but there is the link there on the PowerPoint slides if you want to go back and look that video up and rewatch it. So some questions to think about that we've discussed in this lecture that you can find in chapters 1 and 2 in our textbook are: what are the different sources of knowledge? Can you think of any new examples of each of these? What are some of the benefits and limitations of each of these sources of knowledge? What are the 3 main aspects related to understanding and performing science? What is falsifiability, and how does that relate to things like pseudoscience? What are the main goals of science? What are the 2 main types of research? And what is one reason why our intuitions and beliefs can lead us astray? Okay, so that wraps up this video, and see you all next time.